Very good day, students. I'm Shomandeep, your faculty for robotics, as you all know me. And now this session is kind of a partial revision session for the previous pin configuration. Now, what I have done is I've added few things over here. So let us very quickly go through the pin configuration once again, and let us figure out what new to study, what we have to study again. Okay. And after that, we'll be totally moving on, totally shifting on to the next software session. Okay. So here is the slide for you. So now, previously, what we have done is previously we have studied about the Arduino pin configuration, right? So if you remember very clearly, this was the diagram of Arduino. Let's keep this session a very small one. Okay. So we've learned about the pin configuration. Now, previous session, we have seen how the pin configuration works, dear student. Okay. There's the USB port to connect it with the laptop or computer. There's a crystal oscillator, which is responsible for the timing of the programming, right? Then there is the voltage regulator, the power button or the power cord from where power is being supplied to the microcontroller. Okay. Then there's TXRX LEDs. Now TXRX LED, what does it do? LEDs are basically used to indicate the switching on and switching off. Okay. They're basically used to indicate the switching on and switching off. So whenever I'm talking about TX and RX LEDs, so basically they will be giving us the information that the TX and RX pins, that are the transmission and the receiving pin, they are working on. Okay, they are receiving a high signal, or they are not receiving any signal. In that case, it will be low, or else it will not glow, basically. Okay, zero voltage pass. Then there's the reset button. Now, within ongoing programming, okay, during any project, don't press the reset button, or else you'll again have to like upload the program into it. Okay, all right. Now, this is what mainly I want to show you in this session today. Okay. So if you see, this is also a pin configuration diagram. We call it the pinout diagram, whatever you can call it. But it's in a bit more details. If you remember, okay, we also studied the Atmega 328 microchip, okay, with great details about each and every pin. So this is the main reason I want to show this slide and conduct this session. You see, this part over here is a crystal oscillator, right? Okay. What is the purpose of a crystal oscillator, dear student? First of all, its frequency comes in 16 megahertz. Okay. Now it will be a task for you to calculate how many hertz does 16 megahertz mean. Okay. How many hertz 16 megahertz mean? Okay. That would be a task for you at home. After this session, do it. Very easy. One line, one step conversion, numerical. Then comes, you see, Atmega 16U2 microcontroller IC USB controller. Okay, so this one is a shorter microcontroller or shorter microchip, I should say, that basically aids the Atmega 328 microchip. Okay, 7 to 12 volt DC input, 2.1 millimeter or into 5.5 millimeter jack. Okay, that's a male center positive. Okay, when we'll be doing projects, I'll be showing you some of the wires, some of the jumper wires, some of the cables, some of the USBs, which gets segregated, which gets separated based on the configuration as male or female. Here, now this is not connected to anything, so you can basically modify it for any purpose on any project. IQ reference voltage, reset pin, 3.3 output, 3.3 volt output. That is, if any device or if any sensor requires 3.3 volt of potential difference, so you can provide it via here. 5 volt output is given. Okay, so it will provide 5 volt to the sensors basically. Okay, ground and input voltage. Input voltage means you can give the 5 volt over here. Then comes analog pin 0, analog pin 1, analog pin 2, analog pin 3, 12C SDA and 12C SCL. Okay. All right. We have the USB B port over here. Okay, we basically use USB B port for the broader side. Then comes the reset button, very important and very useful button sometimes. ICSP for USB interface. Then 12C SCI serial clock and 12C SDA, that is serial data. Okay. Pin 13, that is D13 pin. What does the D13 pin do? It is basically connected to the inbuilt LED. I've told you again. Okay, so let's revise it. It's basically connected to the inbuilt LED. Okay, so it indicates the passage of voltage from there, right? Okay, SPI is there. SCK means serial clock. Okay, SCK stands for serial clock. SPI stands for MISO, that is master in slave out. All right, so basically we'll be learning, I'll be giving you examples of swarm bots and everything. Okay, then you'll learn it. Okay, SPISS, that is slave select. Which one you want to order? Interrupt 1, interrupt 2, TX and RX. Right, they are also digital pins, but they are specifically classified for transmission and receiving pins. All right, now these are the things that we have already studied about Atmega 328 microcontroller, voltage regulator, GND, that is the ground pin, TX and RX, that are the transmission and receiver pin, USB interface, we've learned, reset, we've seen, SCK means serial clock, we've learned, MISO, just a minute, it stands for master input or slave output. The slave line is the MISO pin is used to send the data to the master. I will be showing you in our further slides during the projects, after a few projects, what is known as or what is called the master slave configuration in case of a swarm robotic system. Okay. All right. Then you will be learning about MISO. VCC, you all know. Crystal oscillator, you all know. You've learned all these things. Okay. ICSP, I wanted to show you this also. ICSP stands for in-circuit serial programming. The users can program the Arduino board's firmware using the ICSP pins. So these are the basically ICSP pins, ICSP headers. Okay. The program of firmware with the advanced functionality is received by microcontroller with the help of the ICSP header. The ICSP header consists of 6 pins. You see MISO, VCC, SCK, serial clock, MOSC, reset of course, and ground. So wherever there is a VCC, we need ground to complete the circuit. Okay, this is the basic structure of ICSP chip. All right, SDA. This is what I have added. It stands for serial data. Now it is a line used by the slave and master to send and receive data. It is also called as a data line, which SCL is called as a clock line. Okay. What is SCL? Now we have talked about SCL over here. What is SCL? It stands for serial clock. Okay. Now it is defined as the line that carries the clock data. It is used to synchronize the transfer of data between the two devices. The serial clock is generated by the device and it is called as master. All right. I think we are clear with it. SPI and MOSI. What is SPI? SPI stands for the serial peripheral interface. SPI, serial peripheral interface. Now, it is popularly used by the microcontrollers to communicate with one or more peripheral devices quickly. It uses, that means if there is a device beside the microcontroller, so SPI can be used, SPI could be used. They use SPI to facilitate the connection or communication between the device and the microcontroller. Okay. What is MOSI? It stands for master output or slave input. The MOSI and SCK are driven by the master. I'll show you. Then comes, dear students, the SS. What does SS stands for? It stands for slave select. SS, slave select. It is the slave select line which is used by the master, which acts as the enable line. That means you can partially select one slave if there are many, okay, with the help of a master, and then put into it or may change its anything. Okay, you can control it. All right, dear students. And then comes 12C. What does 12C means? It is a two-wire serial communication protocol, which stands for inter-integrated circuits, right? The 12C is a serial communication protocol that uses SCL, serial clock, and SDA, that is serial data, to receive and send data between two devices. Okay. All right. So that's it for today. Like, that's it for this session. Okay. I just wanted you to remember the architecture of Arduino clearly, as from the next session itself, from the next video itself, we will be moving totally to the software part. I will tell you how to install and everything. Don't worry about it. We'll have a separate video for that. Okay. So this is it. This was it for this session. This was a very short and crisp session. I've just added some of the information over here. So that's it, dear students. We'll meet again in the next class.